In this video, we are going to prove that A divide BC if and only if A over D divide C. If D is the greatest common divisor of A and B. Okay, I want to start with the proof from the left to the right. Okay, but the first thing I'm going to do is to let A and B and C be integers such that A is not 0 or B is not 0. Okay, and D is the greatest common divisor of A and B. Okay, now let's prove that if A divide BC, then A would D divide C. So we got to prove from the left to the right. So we assume that A divide BC. So by divisibility, what do we have? We will have integer q such that BC equal A times q. Okay? And take a look at this D. What is it? Since D is the greatest common divisor of A and B, what do we have right here? So we can write this one. So we gotta use theorem 2.4.1. Do not forget that theorem 2.4.1 is dx is integers x and y such that ax plus by equal the greatest common divisor of A and B. Okay, so this theorem implies that. So what does it imply? It implies that dx is integers x and y such that d equal ax plus by. Okay, so this is what we have, right? So now what can we do next? The next thing I'm going to do, I try to show that A over D divides C, right? I need to write C in terms of A over D and multiplying one of the number. So I want to multiply C both sides of this equation. So what I have next is C times D equals C times AX plus BY. And it turns out to be C times AX plus C times BY. Then we're going to have CAX plus CBY. Then we have ACX plus BCY. Okay. Now what is this BC? BC is AQ. Okay. BC is AQ. So since BC is AQ, so what do we have? What happened to CD? CD becomes ACX plus what happened to BC? BC becomes AQY. Okay, and what next? I divide both sides by D, so we can have C equal 1 over D times ACX plus AQY and factorize A, okay? So C becomes A over D times CX plus QY. And this is integer, right? This is integer, okay? So since CX plus QY is an integer and C equal A over D times CX plus QY. What happened? We implies that A over D divide C. Okay? Okay, we have proved it already, right? Now let's prove from the right side to the left side. Okay? So we assume that A over D divide C. A over D divide C. Okay, so what do we have? So this is according to divisibility. We're gonna have integer k such that C equal A over D times K. Now what happened to BC? I will multiply by B both sides. Okay. The reason I do this because I want to show that A divide BC. Let's try to write BC. Okay. So BC becomes B times A over D times K, which is A times B over D times K. Okay. Then, what can we do next? The next thing I'm going to do is to take a look at D, which is the greatest common divisor of A and B. So, since D is the greatest common divisor of A and B, what do we have? D divide B. Okay. Once D divide B, what do we have? Dx is integer, let's say Q1, such that B equal to Q1D. Okay. What happened to BC right now? So BC becomes A times B over D times K, which is A times, what is B? B is Q1 times D over D times K. So this D will be cancelled and it turns out to be A Q1K. Now Q1K is an integer, right? Okay. Since Q1K is an integer and we have BC equal to A Q1K, that means that A divide BC. So we have shown that A divide BC. Now once we prove this arrow from the left to the right, when we prove that A divide BC, then A over D divide C. And we have proved that if A over D divide C, then A divide BC. Therefore, what do we have? Therefore, okay, A divide BC if and only if A over D divide C. That's what we have right here. So we have proved this statement already. And that's it for this video.